All right, so today we're going to be proving triangle similar. The wavy symbol means similar, and angle similarity is abbreviated AA, and then you put the similar symbol after it. That has to be there. Okay, what that is about is that if you have two angles of one triangle congruent to two angles of another triangle, then these triangles would have to be similar by triangle JKL would be similar to triangle XYZ by AA similar. Okay, and that would be how you would write a similarity statement and why. So there is a difference. You must have the similar symbol on these, and you're going to use the similar symbol between the two triangle statements. This is called your similarity statement, and you have to have the letters correspond properly. Side, 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 similar. SSS with a wavy. Wavy, similar symbol. Corresponding side lengths of two triangles are proportional. All of them. Proportional. Spell it correctly. Meaning they're going to be in the same ratio. So in this picture, if you like using highlighters, I am going to use some highlighting. The AB side corresponds to the RS side. That's what they're stating down here. The BC side corresponds to the ST side in the second figure. And the AC or CA side corresponds to the RT side or TR side. The statement, triangle ABC, is similar to triangle RST. And that one would be by, and then you would write a reason. Right after it, you'd write by side, 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 similar. Okay, let's do a couple of examples of how to use this. All right, actually, there's one more to do before we do the examples. Anybody need this still? Okay, side, 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 angle, side. So we got one more. There's only three. Side, angle, side, similar. Only three ways to prove similarity. Two sides of one triangle are proportional to two corresponding sides in another triangle, and the included angle between them would have to be congruent. So in this picture, we've got angle X and M congruent. We've got side ZX would have to be in the same ratio to MP as side XY is to MN. Okay, I know it's kind of can't see what I colored that angle, so I'm going to put a bigger arc mark on there just so you can see it better. If you're coloring, you might want to do that. All right, so it's a two sides, and the angle is between them, included between them. Now these triangles would have been congruent. Triangle XYZ is similar, not congruent, similar to triangle MNP by SAS similar. Okay, let's have an example of how to use each of these, and then we'll use them to find some missing lengths. Determine whether the triangles are similar. Kids get a little confused when they look at the picture and they see all of these numbers all over the pictures. Those are about the lengths of the sides. We need to know which ones correspond to which. Well, we kind of have some hints down here already. Side AC would correspond to side BF in the second triangle. So that's why they compared the 6 over the 9. And then we went 6 over 9 and reduced it to 2/3. Next, we're going to do BC, which is labeled with an 8. Compare it to FE or EF, which has a 12 on it. BC and EF, 8 to 12 would be the ratio. You can divide 8 by 4 and 12 by 4, and if you do, you're going to get 2/3. So I just proved that those are in the same ratio as the other two sides that we already compared. Okay, these are my blue ones. And then I'm going to go and highlight AB and DE with pink, and those are in the ratio of 10 to 15. So 10 over 15 we're going to find out if you divide the top and the bottom by 5, you're going to get 2, 2, 3. Again, don't forget, you can use your calculator in order to find those values. All right, those were my pink ones. All right, now I'm going to make a statement. Okay, so triangle, if we say ABC, triangle ABC, because that seems to be what we do if we see an A and a B and a C. That would be similar to triangle DEF. And it would have been, because we have all 3 sets of sides in the same ratio, it would have been by side, 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 similar. That's probably the one you have to show the most work on. It is the one you have to show the most work on to use SSS similar, because you have to show that all 3 sets of sides have the same ratio. Okay. Example 2, we're going to determine whether these triangles are similar. So on this one, we've already got an angle given. The 70-degree angle, angle N and R are congruent. Okay. MN corresponds to QR. And NP corresponds to RS. Now, if we were to compare them, I don't like the way this was written here, but if I say 3/4 for MN to QR and 6/8 for NP and RS, the 6/8 does equal 3/4 by dividing top and bottom by 3. Okay, so that means we got the same ratio of the sides. Therefore, triangle MNP is similar to triangle QRS. And this time it wouldn't be by SSS similar. We didn't show 3 sets of sides. We only showed 2. And the angle between is congruent, so it's side, angle, side, similar. Not congruent, similar. Angle's congruent, but side's proportional. I may still need this. All right. Yes? Okay. You probably don't if you aren't making it colorful. All right, more similar triangle examples. Here's the deal. Similar triangles can be used to find measurements. Triangle ABC is similar to DEF. All right, that's your statement. You can get a lot from it. Side AC would correspond to side DF. And side BC would correspond to side EP. And lastly, AB corresponds to DE. Now, you've got 2 setups already written over here, which I really didn't need them to be written here. I think we could have just done it. So I'm going to do the problem over here. I'm going to compare the green to the green. So I'm going to do 18 square roots of 3 over x has to equal, and I'm not going to do the y side because I want to find the x. So that'd be 18, the blue one's 18 over 9. Okay, I know a lot of you are not very comfortable with fractions. So I'm going to show you something about these today, because we're going to have some answers in this unit or the next that have exact answers and not just decimals that you type on the calculator. Okay, and in Algebra 2, I know we have some students in here, they're dual enrolled in Algebra 2 and in Algebra and Geometry. You're doing it. You're going to be dealing with radicals and stuff. So we already know about the cross products property. That was in our 7-1. Cross products are equal when we have a proportion. So we know that x times 18 or 18 times x is the preferred way to write it, would equal 9 times 18 square roots of 3. Now, I want to show you something without multiplying on the calculator. Do you notice there's something matching on both sides? Yeah. And we need to get rid of that 18, right? We would divide by it. So if you're dividing by 18, and the top right here, guys, is all a product, multiplying, everything's up here multiplied. It's all 9 times 18 times the square root of 3. If you divide 18 and 18, can't you just cancel these out? right? So that's what I wanted you to maybe see, that sometimes it's easier to do things without the calculator. So 18s cancel here. That's the whole point of dividing by 18, right? So we get x equals, these 18s can cancel. And we have our answer now, 9 square root of 3. 9 times the square root of 3 is how that's read. And I have the exact answer. I don't have to worry about my calculator. Okay, now, would you get the same answer if you did it on your calculator? It won't, it'll be a decimal. It won't give you this, okay? So sometimes we want to be able to do it without the calculator so we can get an exact answer, because this is a nasty decimal. It's called an irrational number. It doesn't terminate, never stops, so you'd have to round it. All right, let's try the other. We got AB, where the y is to 18, pink sides compared, as BC, 18 is to 9. You always want to use a pair of sides that has numbers on them. I'm going to show you how to do this one without the calculator again. So let's cross multiply, and we'll have 9 times the y, and we'll just write 18 times 18. We divide both sides by 9. Can you divide 18 by a 9? Goes evenly twice. Okay, so I can go 9 goes into 18 twice, and then I can do 2 times 18, maybe in my head, maybe not. 2 times 18 is 36, if you're good in your head. And I will prove to you that that works just fine on the calculator. So let's say you did 9y equals 18 times 18. You would have typed 18 times 18 on your calculator. So I don't want to freak anybody out if they're finding this a little confusing. You're still going to be able to do your geometry. You would have gotten 324. And then you would have divided by 9. And your calculator would give you 324 divided by 9. And that would have been 36, just like I got already. Okay, so it doesn't matter to me, really. It's just, I'd like maybe to have you start thinking about that idea. Okay, boom. All right, I think we have just 2 more examples, and one has to do with shadows. You got a person 6 feet tall casting a 1.5 foot shadow. Now think about it. If the sun was out, say I can make a sun. It casts its rays, okay, and then it creates, that's how the shadows are created, right? Okay, so they make these, this has definitely been used in real life over time in order to figure out indirect measurement. Indirect measurement means I can't go climb up that flagpole and measure it as I go with a ruler or something. That's going to be kind of strange to shimmy up that thing and try to measure it, right? So let's say you wanted to know how tall it was. I'm going to put an X on it. And then you knew you were 6 feet tall, and you measured your shadow. And then you could measure the shadow on the ground pretty easy because it's on the ground. You don't have to be sliding up a pole. All right, so then you could figure out the height of this using similar triangles. So to find the height, I'm going to compare my shadow to my shadow and my height to my height. So I might as well just do 6 over x equals, I did height to height. Now I'm going to do shadow to shadow. And I need to start back with that first figure. So since the 6 came off the first triangle, I need to put 1.5 feet on top, 7 on the bottom. Cross products are equal, so I do 1.5 times x equals 6 times 7, which is 42. I grab my calculator and I divide 42 by 1.5, or I divide on both sides by 1.5. Okay, and that should come out to 28, I think. Oops, I hit some weird button that's going to be unhappy with me. Is it 28, people? Yes, thank you. All right, 28. So that would be x, and which is actually representing the height of the flagpole. So the flagpole would be 28 feet tall. Oops. Number 5, identify the similar triangles and write a similarity statement. Find x and find each measure. All right. I see these triangles. and I see an angle and an angle. I got a right angle and a regular angle, and they're marked congruent. So I know these triangles are congruent. XYZ is not congruent. I keep saying that. I want to say similar. XYZ is similar to JKL, and they would have been similar by angle, angle, similar. Okay, because they have two pair of angles that are congruent, then they're similar by AA similar. In order to find X, I will compare the side with the 13 to the side with the X. So I'm going to write 13 over X. And then I'll compare two sides with the 10. Which one am I going to use, the 35 or the 20? Okay, that 35 is on the hypotenuse. That would not help. Okay, so I'm going to do 13 over X, 10 over 20. I cross multiply, I get 10 times X. 13 times 20 is 260, right? I divide by 10, and I get X is 26. And that happens to be JL, so 26 again. Okay, that was the end of your ISN. Now we will go to the 7-3 packet that you grabbed on your way in. In order to not waste time, because we will get all through the problems up to the homework, all the examples that we need. I don't think I need to fill this in again, as you have it all in your ISN, right? And you already have it all filled in on the front side of that paper anyway. Let's go right to number 1. Determine whether the triangles are similar. If so, write a similarity statement, explain your reasoning, show proportions, state the similarity theorem, etc. As I mentioned, the easiest kind is when there's two angles. So this would be yes. Triangle ABC is similar to triangle DEF by what? Yep, two angles. So A, similar. Be focused, don't just be writing. That's it. The next one, we have more to do. We don't know if they're similar yet. We have to compare the sides. So sometimes people get confused as to which side should go together or which side should be compared. So think like this. Smallest side is 20 on this one. The smallest side on the second figure is the 18. So I'm going to do 20 over 18. I want to see if it's equal to 36 over 24. So we write the proportion. I would like you to do it by reduction, not cross products, okay? You can do cross products and see if they're equal. Or you can just reduce. But since reducing is going to help me with a lot more of the problems I want to reduce. So I can divide 20 and 18 by 2. That would give me 10 over 9. And then 36 and 24, I could divide both of those by 12. That would be 3 over 2. And remember your calculator, if you didn't know that, you can hit 36 divided by 24. Oops. You hit your math, enter, enter. And it reduces it for you to 3/2. Are those equal? No, they're not equal. That means these triangles are not similar. You have to check. Do not assume. All right. Do I need to wait a second before I turn? See some people still writing, so I'll wait. Okay. Number 3, determine whether the triangles are similar. All right, we're still going to follow the same directions. We've got some parallel lines. What do I know because of the parallel lines? Anyone? Do I have any angles that I can mark congruent? Where? I know a lot of you see where to mark them. Find me some corresponding angles. Angle U and angle what? Where? I heard R, not R. Corresponding be by the L, so it'd be angle SLT. All right, now, but I think you might be right about what you're thinking. You're just not maybe saying it correctly. If you said R, you're thinking up here and here. All right, I hope so, because angle R would be congruent to angle STL. And then angle T is congruent to itself. No matter what I do, these triangles are similar. All right, triangle. Let's do RUT, rut. I said, not put. Okay, angle RUT is similar to triangle SLT. And the reason is by angle, similar. Okay, number 4 is on your next page. You got to turn. What you first should look at is, what do I see marked on the figures? I see a congruent angle. All right, I've got an angle congruent to an angle. I need to check if the sides are in the same proportion that correspond. So I need to check if BK is to PR as KJ is to RZ. I just colored them just to see. So I'm going to do 8 is to 4. 8 over 4, is it equal to 18 over 9? Well, those numbers are half of each other, aren't they? Meaning 8 divided by 4 is 2, 4 divided by 4 is 1, 18 divided by 9 is 2, 9 divided by 9 is 1. They are in a ratio of 2 to 1. That would be the scale factor. All right, 2 to 1. They reduce to 2 to 1. So I know they're similar. So yes, triangle KDJ is similar to triangle RPZ by, yep, you got a side and 2 sides and an angle included. SAS, similar. Okay, number 5. That was 4. Determine, again, whether they're similar. This looks a lot like what I just had, except there's just not a number. It's just marked with an arc. Who cares? That means the angles are congruent. So we're going to want to compare and see if the sides are in the same ratio. So I'm going to do 24 over 16. You don't have to highlight these unless you feel it is helping you. 39 over 26. I mean, if you get it, just do it. My pen is stuck. One moment. All right, so I'm going to compare 24 to 16 and see if it is the same ratio as 39 to 26. I can divide by 8, top and bottom. I get 3 over 2. I can divide these by 13, 3 over 2. So this is yes. Triangle BFE, sounds like beefy, is similar to triangle NLM. And that would again be by side angle, side similar. Okay, you guys don't like to write too much sometimes. And sometimes you are too lazy to write down the things that you need to write down to be fully answering a question. I did notice that on our chapter 6 test. And then others of you are fine with writing out all kind of stuff. You got to be clear if you're trying to explain something to someone. Okay, so if you're trying to show me that you know what you're talking about, you need to do these things. You can't just write yes and write the thing and write SAS similar, okay? You're going to have to show the ratios. That's proving something. So it's kind of like when I said, what is the figure? Is it a rectangle, a rhombus, or a square? Or how do you prove what it is? You had to show numbers. You just don't copy down the theorems out of your ISN. I mean, you got to give a reason, show some numbers, like count the slopes or whatever. For this one, what do we need to do? We have to do 3 things. What should I compare? We ought to know by now. Okay, so go to the smallest one in the first triangle. That would be the 24. Something just disappeared on me. Okay, so I'm going to compare GI to what side in the second one? Yeah, the smallest one. Okay, so QS. So I'm going to do 24 over 15. I'm going to check if it's equal to, now I'm going to get another pair of sides that correspond. So I'm going to go to the medium length in the first triangle, which would be the 32. I'm going to compare that to the medium number in the second one, which would be 20. So I'm going to do 32 over 20. And then last, I'm going to do the 40 and compare it to the 25. I can never write a 4 with those markers, so I've got to go back to a pen. Makes me take longer. Okay, 40 to 25. All right, so reducing these fractions. Again, you got a calculator, it will do it. You type 24 divided by 15, you hit math, enter, enter. Otherwise, you say, I know, they divide by 3, both of them. So 24 divided by 3 is 8, 15 divided by 3 is 5. 32 and 20, common factor is 4. 32 divided by 4 is 8, 20 divided by 4 is 5. And the last one, 40 and 25, you can divide by 5. 40 divided by 5 is 8, 25 divided by 5 is 5. So all of those reduce to 8/5, which means the scale factor is 8 to 5, 8/5, and yes, they are similar. Triangle GIH is similar to triangle, I did GIH would be QSR. And that would be by side, 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 similar. Okay, that one's got the most to write. You have to reduce 3 sets of sides. Chloe? If you have an emergency, yes. 7, use similar triangles to find measurements. Well, I don't know where 7 went. Do you have a 7? Or does it go right to 8? We probably put 7 in the ISN when we pour up the packet. All right, identify the similar triangles and write a similar, same directions. Okay, this is going to get a little trickier because these triangles overlap. So I'm going to highlight one triangle, which is this one. And the versus the big one. I think I'll make that really bold. Okay, now why I did that is because I'm comparing the triangle that's blue, Emily, to the triangle that's pink. Triangle, I'm thinking, well, they look similar. We've got this, I don't know, these are both isosceles. It's saying to identify the similar triangles, so I guess they are similar. We're not proving that they are, so they're telling us they are. So it'd be triangle GHW. That'd be the little one. And it doesn't matter which order. If you do your letter order different, just make sure it corresponds properly. And then this big pink one would be GIU. Okay. How am I going to do a proportion to find X? If I'm comparing the sides, it's GW. It compares to what side? This is the tricky part. It's GU. So because you're doing blue triangle to pink triangle, you can't just do this little piece. All right, that 13 wouldn't cut it. So we need to figure out what G to U is. All right, so that GW is to GU as, and I'll go over here, GH is to GI. Or, I can't, oh wait, there's no numbers on that side, so I'm not going to use that one. So what else could I use? The 20 and the X, which would be HW, HW and IU. Okay, I hope you're following what I'm thinking. You don't have to write this letter thing out. I'm trying to make you see what I'm talking about. All right, so GW has 26 on it. So 26 is to, what's the length of GU? Yeah, 26 plus 13 would be 39. Got to make a whole side to a whole side. And then I'll do 20, the smaller figure I started with on the first one. So I'll do 20 over X. Okay, so now I'm going to do my cross products. So 26 times x equals 20 times 39, 780. And then divide. Is it 30? Okay. All right, so the length of x is 30, and that was IU, so that would be 30. So, number 9. I have some parallel lines, which tells me I've got some alternate interior angles that are congruent because of these transversals cutting through those parallel lines. This angle down here would be congruent to that angle up there. Now, the reason I mark those is to help me make sure I'm doing my triangle congruence correctly. So if I triangle ABC, if I say ABC, like you tend to do, what angle do I start with in the other one? I went A to B to C. It would have to be D, and then BE. Order matters with your letters. Things must correspond properly. All right, I'm going to find X. X is here. What corresponds to X? It's the side with a double arc mark and that goes to the B. So it'd have to be the 38.6. So X over 38.6 equals, I'm going back to the figure that X is on, and that would be the 30 compared to the 60. Now, you could do some reducing or just cross multiply and divide. So 60 times X equals, 30 times 38.6. 1150? 58? Okay. 1158? All right, 1,158. Divide that by 60. Oh, came out to be a decimal. All right, so X is 19.3, and that was what BC was labeled, 19.3. Right, 10. Now I have a little bit more work to do as far as which triangle, how we're going to compare things. Oh, I got that ginormous marker again. Okay, so that triangle has an X and a 16 on it. We're going to have to compare it to that triangle. All right, so triangle KMV, the big one. I'm just starting with the big green one. It should be similar to triangle LMP. And remember, if you have these flopped, that doesn't matter. Amen. So, I need to think about these green sides, guys. How big is this green side from K to M? It's not, yeah, we don't want to multiply them. We want to add them. Okay, so it's going to be X plus 9. Okay, K to M is X plus 9. What's V to M? 8 plus 16, which is 24. Okay, we have to have a whole side to a whole side. So here's how we have to set this problem up. I got this green KM. I'm going to do X plus 9 is to X, LM, as the whole thing down here, 24, is to 16, which is here. That's PM. Okay, now we got to do cross products. I got 24x equals 16 times x plus 9. I need to distribute, and maybe you did that right away, which would be 16x plus 144. All right, then I would need to subtract 16x. And I get 8x equals 144. All right, you guys, divide for me, please. 18? All right. And then is that LM? Oh, it is LM. Sometimes you have to plug back in. Like what if they asked me for KM? I would have had to done 18 plus 9. Should have asked for KM. Okay. Not too much left here for the homework. 2 more questions. We have AC corresponding to, let's go for looking at the sides that correspond, and I'll color if I need to. ED corresponds to AC. And the other one we're going to look at, EB corresponds, bless you, to CB. Let me get a statement going here. Similarity statement, triangle EBD. If I said E to B to D, I have to say C, B, A for the other triangle. So I start with side ED compared to AC. So I'm going to do x plus 5 over x plus 1. And then I'm going to do back to the same triangle I started with. Okay, so if this is your first, this is your second. I went first to second. I have to be consistent. EB's on the first, so that would be 15 to 12. That's your first figure, second figure. I just thought maybe I better at least label it one time. Cross products. All right, 12 times your 5x, or your x plus 5. It will equal 15 times your x plus 1. All right, that gives you 12x plus 60 equals 15x plus 15. When I distribute, I need to subtract 15x. Oh, wait. Maybe I better do that since I get a negative if I did that. So don't be afraid to have your x's on the right. So I think most of you would rather subtract 12x. I'll have 60 equals 3x plus 15. I need to subtract 15 from both sides. We get 45 equals 3x. Don't worry about that 3x being on the right. Divide by 3. I got 15. All right, that's my x. Uh-oh, finally, I think we have to do something. AC isn't just 15. It's going to be 15 plus 1, which is 16. All right, last example. You got vertical posts. How do I draw vertical lines? What's that mean? Up and down? Not right and left? Up and down. Okay. So I got 2 posts. One smaller than the other. One's 2 meters. One's 0.45 meters. When the shorter post casts a shadow that's 0.85, oh, shadow 0.85 on the ground. How long's the longer post shadow? Oh, I want to know this, x. Well, who makes shadows? Or how, not who, it's not really a person. What makes a shadow? The sun's rays. Oops. Oh well. There's my sun rays. These are right angles. My sun rays have created me some triangles. I'm going to do 2 is, I can do this multiple ways. You can do 2 over x equals 0.45 over 0.85. Do you see what I did? Boom, 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 boom. You can go across, height to height. 2 is to 0.45 as x is to 0.85. The whole thing that matters is that your proportion is set up correctly as long as the same thing's across as I have. So, or that the cross products are 0.45x equals 2 times 0.85, which is 1.7. And then you have to divide by 0.45. It's something icky, isn't it? Was it 3? And then it's 7, 7, 7, 7. All right. It says to the nearest hundredths. So that'd be 3.7. This is your hundredths place. There's a 7 behind it. So it would go up to 3.78 meters. Okay, the rest of this is your homework. Work on it, please. Be prepared with questions. And I will take these questions on Thursday with all 7.4 that we'll do tomorrow.